Hello, welcome back to Chapter 8, Section 6, where we're talking about radical expressions and rational exponents. So in the previous video we did this. I grabbed the papers. We did this. We had exponents that were fraction, and we call them rational exponents because it's a ratio. So we had exponents that are fractions, and then we converted that into radical form. In this video we are going to go the other way, the other direction. We're going to start out with the radical form and rewrite it using rational exponents. So remember, and I'm going to write it over here to the side. Oh, actually, let me write it the same way that of the rule that I had. That's this rule right here. So if I have the nth root of some number to the power of m, and we talked about the fact that that can be directly on that number or it can be over the entire root, and those are the same. This is a, that number, whatever that is. The m is in the numerator or top of the fraction exponent, and the n is in the denominator. So what I'm going to do for this one just becomes 7 to the 3/4 power, or to the 3/4 power. And that's it. Now, we're not going to simplify that one, and there's a couple here that we might be able to simplify, and we'll talk about that. But right now we want to get the idea that I can write every radical as something with an exponent. And by the way, so again, this goes back to that argument that when I've had discussions about putting the R in PERMDAS, one of the arguments for it, which is perfectly correct, and when I say arguments, I don't mean people are shouting at each other. It's like we're discussing, because that's what intelligent, well-minded people do. If I want to define this value, if I wanted to actually simplify it, I would do this. There is a way that I can go through the catalog and get the fourth root. At least I believe so, but it's buried in there someplace. But what I'm going to do instead, I'm going to write 7 to the power of, and then I do 3 divided by 4. I'm going to hit that, move that out. See, 7 to the 3/4. And because of the coding, because of the way of the line, it has to write the fractions sideways. That's really bad. Don't do that. Write your fractions vertically, okay? But that's what it is. That's the fourth root of 7 cubed, or, well, either way. I guess I would say it the same way. I can either take the fourth root of 7 and then cube it, or I can take the fourth root of whatever 7 to the 3rd power is. Either way, it's going to be this. So now you have a powerful tool for finding really strange roots. So this one, I'm going to write 11 to the 6 divided by 3 power. And you may have noticed that is very similar to something that we worked on in, I think, like the first or second video. I lost track. I can go ahead and take 6 divided by 3. I can simplify this part. This becomes 11 to the 2nd power, which it didn't ask me to do this, but I know that that's 121. So one way to look at this would be just like we did in the, again, the first or second video. 11 to the 6th power, I'm going to write it just down here real small. That'd be 11 to the 3rd power times 11 to the 3rd power. And when I take the cube root of both of those, I just get 11 times 11. So that's what's happening. That's why it ends up being a fraction, because a fraction is a way of showing division, and I'm kind of dividing up the factors. It's a little more complicated than that, but that kind of gets to the point. Now let's try this one. This becomes 81 to the 3 divided by 4 power. Now 3 divided by 4 does not, like 6 divided by 3 was 2. This is not going to reduce or simplify. So I'm going to leave that as 81 to the 3/4 power. However, if the directions, and again, if the directions said, after you write it this way, then simplify, because it might, I'm going to use a calculator. I'm going to show you what it's going to be, and then hopefully you're going to be surprised and say, Why don't we do that in our head? If I do 81 to the 3 divided by 4th power, I get 27. Unlike last time where I got like a, unlike this one where I ended up, not last time, this one, where I ended up with like an irrational number. This one's like a nice number, 27. Oh, why? Because the 4th root of 81 is just 3. And I have 3 to the 3rd power, which is 27. But our directions are just write it using rational exponents. So I know that if I reason my way through this, I'm going to get 27. And if I write it with a rational exponent, I'm going to get 27. So I'm using that to show you that, yeah, this is a real thing. Okay? All right. For this one, I have 10 to the 9 divided by 3 power. And of course, like 6 divided by 3, 9 divided by 3 equals something. Got to be careful the way I say it. In this case, it's 3. 9 divided by 3 equals 3. 6 divided by 3 equals 2. And of course, you could have done the same thing. What's kind of cool about this one is I could have done 10 to the 3rd times 10 to the 3rd times 10 to the 3rd. That's 10 to the 9th power. And then took the cube root of each of those, which now is going to be 10 times 10 times 10, or 1,000, 10 to the 3rd power. So all of the common sense about this, that's a bad way of saying it, all of the confusion about this actually kind of makes sense when you start to look at what these symbols actually mean. Okay, for the last one, this is going to be 5 to the 2 divided by 4 power. Now, 2 over 4 does simplify. That's 5 to the 1/2 power. But I don't know what the 1/2 power of 5 is. But I know what it actually represents. This is actually the same as the square root of 5. It has the same value. So one way you can take square roots, 5 to the 1 divided by 2 power. And since my calculator does square roots, square root of 5, it's going to give me the same thing. Okay. We'll see how that goes. See you in the next video.